My name is Shamraiza and I am the student of MS. And today my topic is inorganic industry. Inorganic acids. An inorganic acid, also called a mineral acid, is an acid derived from one or more inorganic compounds. All inorganic acids from hydrogen ions and the conjugated base ions, when dissolved in water, commonly used on inorganic acids are sulfuric acid, hydrochloric acid, and nitric acid. Inorganic acids range from superacids such as perchloric acid and nitric acid. Inorganic acids range from superacids such as perchloric acid to very weak acids. Inorganic acids tend to be very soluble in water and insoluble in organic solvents. And inorganic acids are the most commonly used acids in the laboratories, some of which are as follows, like hydrochloric acid, nitric acid, phosphoric acid, sulfuric acid, and boric acid. Sulfuric acid. Sulfuric acid is most common acid that is used in various chemical experiments. It is a strong inorganic acid. The chemical formula of sulfuric acid is H2SO4. And some are physical properties of uh, sulfuric acid and chemical properties of sulfuric acid. Colorless physical characteristics: colorless, odorless, soluble in water, and is highly exothermic in nature and considered as strong acid. And chemical characteristics of sulfuric acid: highly corrosive in nature, hygroscopic, produces severe chemical and thermal burns when in contact. Next, industrial sulfuric acid production. In industry, sulfuric acid is mainly produced by contact process, wet sulfuric acid process, lead chamber process produces dilute sulfuric acid, 67 to 78% H2SO4. Sulfuric acid plant steam, range of products H2SO4, liquid SO2 and liquid SO3. Raw materials elemental sulfur, SO2 gas, H2S gas, spent acid and sludge. Contact process of sulfuric acid. Sulfuric acid is made by burning sulfur. The sulfur dioxide given off is then reacted with a catalyst at high temperature to give sulfur trioxide. This can then be absorbed to give the acid. Depending on its intended use, it can be further diluted with water. This method of manufacture is called the contact process. Contact process, modern industrial method of producing sulfuric acid. The steps involved in the manufacturing of sulfuric acid are as stated below. Preparation of sulfur dioxide, conversion of sulfur dioxide into sulfur trioxide, conversion of sulfur trioxide formed into concentrated H2SO4, and conversion of sulfur trioxide to sulfuric acid. Manufacturing of sulfuric acid. And first step involved in manufacturing of sulfuric acid is that in first step sulfur is burned to produce sulfur dioxide. In second step, the sulfur dioxide is oxidized to sulfur trioxide by oxygen in the presence of vanadium oxide catalyst. This reaction is irreversible and the formation of sulfur trioxide is exothermic. In third step, the sulfur dioxide is absorbed into 97% to 98% H2SO4 to form alum, also known as fuming sulfuric acid and pyrosulfuric acid. The alum is then diluted with water to form concentrated sulfuric acid. And the fourth step, directly dissolving sulfur trioxide in water, is not practiced. And this is the contact process, and this in sulfur and dry air is added into furnace, and then sulfur dioxide and hydrogen and oxygen to form sulfur dioxide, and then convert into sulfur trioxide, and then concentrated sulfuric acid is converted into alum, and then alum is converted into sulfuric acid H2SO4. And next is wet sulfuric acid process. The wet sulfuric acid process is a wet glass catalytic process. The concentrated sulfuric acid is produced by condensation from a wet process gas. Other sulfurous feeds are oxidized to SO2 by combustion and then cooled to the optimum catalytic conversion temperature in a waste heat boiler. And wet sulfur acid process for manufacturing of sulfuric acid has following steps. And in the first step, sulfur is burned to produce sulfur dioxide, and or alternatively hydrogen sulfide gas is incinerated to sulfur SO2 gas. The sulfur dioxide then oxidized to sulfur trioxide using oxygen with vanadium oxide as catalyst. And the sulfur trioxide is hydrated into sulfuric acid, and the last step is the condensation of sulfuric acid to liquid 97 to 98% H2SO4, and this flow chart shows wet sulfuric acid process. First, sulfurs feed preheated or combustion, then SO2 conversion, and then gas cooling and acid condensation and acid cooling, and product is formed, and the final product is acid. And inorganic base, and the term inorganic base represents a large class of inorganic compounds with the ability to react with acids, that is neutralize acids to form SARs. An inorganic base causes an indicator to take on characteristics color and usually refers to water soluble hydroxides such as sodium hydroxide, potassium hydroxide, or ammonium hydroxide. And the term also includes weak bases such as water soluble carbonate derivatives or bicarbonate derivatives. And inorganic base are the most commonly used base in the laboratories: sodium hydroxide, potassium hydroxide, magnesium hydroxides, and lithium hydroxides. And this is all our inorganic base that is used in the laboratories. Potassium hydroxide. Potassium hydroxide, or also known as lye, is an inorganic compound with the chemical formula KOH, also commonly referred to as an caustic potash. Potassium hydroxide is an odorless white or slightly yellow, flaky or lumpy solid which is often in a water solution. KOH is prototypical strong base. It has many industrial and niche applications, most of which exploit its caustic nature and its reactivity towards acid. Manufacturing of ammonium acid, and KOH was made by adding potassium carbonate to a strong solution of calcium hydroxide, slaked lime, and the salt metathesis reaction results in precipitation of solid calcium carbonate, leaving potassium hydroxide in solution. Filtering off the precipitated calcium carbonate and boiling down the solution gives potassium hydroxide, calcinated or caustic potash. This method of producing potassium hydroxide remained dominant until the late 19th century, when it was largely replaced by the current method of electrolysis of potassium chloride solution. This method is analogous to manufacture of sodium hydroxide. Hydrogen gas forms as a byproduct on the cathode. Concurrently, an anodic oxidation of the chloride ion take place, forming chlorine gas as a byproduct. Separation of the anodic and cathodic spaces in the electrolysis cell is essential for this process. Ammonium hydroxide. Ammonium hydroxide, are also called ammonium solution, ammonia water, aqueous ammonia, or aqua ammonia, solution of ammonia gas in water, a common commercial form of ammonia. It is a colorless liquid with a strong characteristic odor. NH4OH is often denoted by symbol NH3AQ. Manufacturing of ammonium hydroxide, and manufacturing of ammonium hydroxide before the start of World War I. Most ammonia was obtained by the dry distillation of nitrogenous vegetable and animal products, and the reduction of nitrous acid and nitrites with hydrogen, and the decomposition of ammonium salts by alkaline hydroxides or by quicklime, the salt most generally used being the chloride. Haber-Bosch process and modern ammonia producing plants. The Haber Haber-Bosch process. The Haber process is used in the manufacturing of ammonia from nitrogen and hydrogen, and then goes on to explain the reasons for the conditions used in the process. The process combines nitrogen from the air with hydrogen derived mainly from natural gas methane into ammonia. The reaction is reversible and the production of ammonia is exothermic. And the flow chart showed the Haber process. Firstly, nitrogen from air and hydrogen from natural gas. Nitrogen, hydrogen at 400 to 450 degrees Celsius, 200 atm iron catalyst, and gases are cooled, and ammonia turns into liquid, and liquid ammonia formed, and the unreacted gas is recycled. Modern ammonia producing plants. Modern ammonia producing plants are typical modern ammonia producing plants first converts natural gas, for example methane or LPG, liquefied petroleum gases such as propane and butane, or petroleum naphtha into gaseous hydrogen. The method for producing hydrogen from hydrocarbons is referred to as steam reforming. The hydrogen is then combined with nitrogen to produce ammonia. The figure on the next slide shows the stages of modern process for the formation of ammonia, and flow chart that show ammonia products: feed, sulfur removal, then steamed methane, catalytic reformed, shift conversion, and carbon dioxide removal and methanation, and ammonia synthesis, and lastly the ammonia product is formed. Sodium hydroxide. Sodium hydroxide, are also known as lye or caustic soda, is a caustic metallic base and alkali. Caustic soda is widely used in many industries, mostly such as strong chemical base in the manufacture of pulp and paper, textiles, drinking water, and detergents. Manufacturing of sodium hydroxide. Chloroalkali industry. The chloroalkali process is an industrial process for the electrolysis of sodium chloride solution brine. Depending on the method, several products besides hydrogen can be produced. Sodium hydroxide is produced along with chlorine and along with chlorine and hydrogen via the chloroalkali process. This involves the electrolysis of an aqueous solution of sodium chloride. The sodium hydroxide builds up at the cathode where water is reduced to hydrogen gas and hydroxide ion. To produce NaOH, it is necessary to prevent reaction of the NaOH with chlorine. This is typically done in one of three ways: mercury cell process, diaphragm cell process, and the caustic soda. Firstly, we discuss mercury cell process. Sodium metal forms as an amalgam at a mercury cathode. This sodium is then reacted with water to produce NaOH. There have been concern about mercury releases, although modern plants claim to be safe in this regard. Diaphragm cell process uses a steel cathode, and a reaction of NaOH with Cl2 is prevented using a porous diaphragm. In the diaphragm cell process, the anode area is separated from the cathode area by a permeable diaphragm. The brine is introduced into the anode compartment and flows through the diaphragm into the cathode compartment. A diluted caustic brine leaves the process. The caustic soda must usually be concentrated to 50% and the salt removed. This is done using a evaporative process with about 3 tons of steam per ton of caustic soda. The salt separated from the caustic brine can be used to saturate diluted brine. The chlorine contains oxygen and must often be purified by liquefaction and evaporation. Membrane cell process, and this is the last process. Similar to the diaphragm cell process with an F-ion membrane to separate the cathode and anode reaction, only sodium ions NaOH of the three process ion and a little water pass through the membrane, it produces a high quality of NaOH. Of the three processes, the membrane cell process requires the lowest consumption of electric energy, and the amount of steam needed for concentration of caustic soda is the relatively small. And this diagram show that the cathode and anode are separate with an effusion membrane, and it produces a higher quality of consumption of electric energy, and the amounts of steam needed for the concentration of caustic soda is relatively small, and we have NaOH that is formed. And thank you.